Welcome to the Foundry by Forge College. I am absolutely thrilled to have you here today. So if you hung out with us for our last explainer on key derivation mechanics, you know we covered a whole lot of theory. It's fascinating stuff, but today it's time to put on our hard hats. We're moving out of the theoretical classroom and into a super fun under-the-hood engineering workshop. In this explainer, we're going to take all that theory and transition straight into hands-on scripting to seamlessly manage multiple accounts with HD wallets. It's going to be a blast, so let's get right into it. Okay, so here is our master blueprint for today's build. We'll start by moving from mechanics to practice. Then we'll spend a minute gathering your building tools. Next up, writing the actual derivation script itself. After that, we'll be inspecting our final output, and lastly, we'll lock it all down with the golden rules of recovery. All right, section 1, from mechanics to practice. Let's bridge that gap.
So, like I said, we are moving straight to the workbench to actually prove that the math works. The absolutely crucial point here is taking those abstract rules we learned, the hardened pads and the index numbers, and translating them directly into local code. We're going to run the exact same deterministic math that real hardware and software wallets use to achieve true account separation. Because honestly, it's one thing to understand how a seed expands conceptually, right? But it's a whole different level of mastery to watch it happen right there on your own screen.
But before we start typing out code, let's just do a really quick recap of our secret weapon, the Extended Public Key, or XPub. Think of this thing as the magic skeleton key of the crypto world. It allows you to enumerate, basically list out all your public child keys for non-hardened branches. And the best part? It does this completely safely, without ever exposing your private key material. It's literally the exact mechanism that lets an app show you your balances without actually needing the power to spend your funds. Pretty brilliant, right? Moving on to section 2, gathering your building tools. Time for some quick prep work. Every good engineer needs the right materials. But don't worry, we aren't building a rocket here. It's just 3 really simple steps to prep our local sandbox. Step 1, you'll need Node.js installed. Version 14 or higher is totally fine. Step 2, initialize your project by just typing npm init-y right into your terminal. And step 3, install our trusty libraries, BIP39 and BIP32. We use these standard, battle-tested cryptography blueprints to do all the heavy mathematical lifting for us. No need to reinvent the wheel. Now stop right here for a second, because this is our absolute golden rule of safety. Please use a synthetic or test-only mnemonic phrase for this. Never, ever, under any circumstances, paste your real recovery phrase on a networked machine. You always want to use a dummy seed when tinkering. I mean, treat your real keys like physical gold bars. You wouldn't just leave those sitting around on your workbench for anyone to trip over, right? Keep it safe. All right, section 3, writing the derivation script. Let's get to the assembly.
Tools ready? Sandbox prepped? Safety glasses on? Awesome. Let's assemble the logic that's going to act as our very own derivation engine. Here's the basic schematic of how our script flows. Notice how the very first thing we do is explicitly validate the mnemonic input securely. We do this so that if you accidentally paste in garbage text, the script politely fails and gives you a clear error, rather than just crashing silently or worse, generating junk keys. From there, we convert the mnemonic to a root seed, derive the root node using our BIP32 library, apply our account-level path template, and finally, we loop through an index, say 0 to 2, to spit out our child keys.
And this brings us to a really brilliant illustration of a core trade-off in wallet architecture. We basically have 2 derivation path choices. First is the account level, which is hardened. You can spot this by those little apostrophes in the path. This hardening physically protects against private key derivation. Then we have the address level, which is non-hardened. Notice there are no apostrophes there. That allows for public enumeration from the XPub. So we harden the main account for maximum security, but we intentionally leave the address paths non-hardened so we can safely generate our list of public accounts. It is literally the best of both worlds. On to section 4, inspecting the final output. It's time for the test run. Okay, the code is written. It is time to hit run in our terminal and witness that magic moment where one single seed expands into multiple distinct branches. Just look at this beautifully predictable output log. As we loop through index 0, 1, and 2, you can actually see the derivation path updating accordingly right at the very end of the string. And because of the deterministic math powering all of this, each distinct index number automatically guarantees a completely separate, totally unique child public key. You can see those unique hex strings generated as a result. Let's pause real quick for a result verification checkpoint. If you happen to be coding along with us, double-check your own terminal output against this checklist to make sure your spelling and your derivation concatenations are absolutely flawless. First, your indexes should be strictly sequential. Second, those hardened markers, the little apostrophes, they absolutely must appear correctly in the path. Third, your child public keys should be visibly distinct from one another. And of course, your script needs to exit gracefully if you feed it an invalid seed.
Almost done. Section 5, Golden Rules of Recovery. Let's wrap things up.
Before we pack up our workspace and wash the digital grease off our hands, we need to lock in some safe derivation practices. Always document your exact path template. Map your index numbers to specific accounts, like maybe index 0 is your savings, index 1 is your checking, you get the idea. Also, never reuse indexes across different account types because that is just asking for a massive accounting headache later on. And finally, store your XPub offline as a recovery artifact. Actually, establishing these operational habits isn't just for this one script. Understanding this deep architecture is a foundational part of the broader Web3 security and development courses you can dive into as you keep learning with Forge College. I absolutely love this concept. Separation by index is deterministic and reproducible. It really is the absolute truth of cryptography. There's zero guesswork here. You aren't relying on some third party's private database. As long as you have documented your path and your index number, you can reliably rebuild these exact same accounts decades from now on any compatible software. It is math that you can fundamentally trust.
But that does leave us with a pretty fascinating question, doesn't it? What happens when we need to derive paths for completely different blockchain currencies? We've successfully conquered local accounts for a single chain today, sure. But how does this exact same blueprint adapt if we suddenly decide we want to hop over to a totally different ecosystem?
Well, I hate to say it, but that is a puzzle for our next build. Definitely keep your script handy and saved securely somewhere, because next up we'll be extending HD wallets for multiple currencies. We're going to use this exact same foundation to cross blockchain borders. Thank you so much for joining me in the workshop today. If you want to dig deeper, be sure to visit forge.college to learn more about this subject, access our full course materials, and explore tons of other amazing Web3 related topics. Until next time, keep building and stay curious.